Vapor pressure is one of the most commonly measured physical property in refineries and terminals. Ever stricter regulations combined with tighter process control make this measurement a key tool in increasing profitability of blending operations and refineries as a whole. Hi, I'm Corentin Thierry, Sales Manager at BARTEC US for our Process Analyzer division. Let's take a look at one of BARTEC's solutions for the monitoring of RVP, one of our best sellers from our BARTEC Benki factory in Germany, the RVP4 RVP Analyzer. Before we get into the RVP4, one of the common questions we often get asked is, what is RVP and what is vapor pressure? Vapor pressure is the measurement of the amounts of vapors released by a liquid at a given temperature. Now, how is this measured in the lab? In the lab, we measure specifically RVP, read vapor pressure, and to do that, we use an apparatus as displayed here with a gauge, a bomb, and a sample container where the sample will be exposed to a 4:1 expansion ratio that allows the vapors to expand. All of this while the sample is maintained at a constant temperature of 100 Fahrenheit or 37.8 degrees centigrade. When the pressure stabilizes in the apparatus, we have reached what is called the RVP, the read vapor pressure. Now, there are different types of vapor pressure. You will hear names such as I said, RVP, read vapor pressure, but also TVP, true vapor pressure, VPCR, vapor pressure of crude oil, DVPE, dry vapor pressure equivalent, amongst others. The most common measurement, though, is RVP, read vapor pressure. And the question is, why is that? So why is RVP important? Well, RVP is important for multiple reasons. The first one is a regulatory reason. So gasoline have emission requirements, and those requirements basically are tied to the vapor pressure of the gasoline. So for example, in the EPA, at different times of the year, in different locations of the country, gasoline has a specific RVP requirement. The second reason is quality. If we take the example of gasoline again, engines are designed to run with a gasoline of a certain RVP. So if the RVP of the gasoline is not properly set or properly prepared, the engine does not run as expected. So RVP is also a quality measurement. And then finally, RVP is a safety measurement. As I said earlier, vapor pressure, read vapor pressure, is a measurement of the amount of vapors that a product releases at a specific temperature. So this measurement is also used to evaluate the pressure that a sample stored in a storage tank or in a pipeline will exert on the pipeline or storage tank. And by knowing the RVP, the containers can be designed to handle the required pressure so that we avoid explosions or leaks and bursts. So quality control, regulatory control, and safety. Those are the three reasons why RVP is so commonly measured. To my right, you can see a 3D rendering of the BARTEC Benki RVP4. The top right enclosure is the electronics enclosure that contains all the processing of the signal as well as the HMI and a computer. To the top left, you can see the measurement enclosure where the actual piston makes the expansion. At the bottom right, you have a purge controller because this system has an EXP purge type protection. At the very bottom, the blue box is an optional chiller that is installed in some cases, especially with crude oil application. And to the middle on the left, we have a modular section which can be used for sampling system, for air purification, for a variety of accessories and or equipment. The RVP4 is about 4 feet wide by 6 feet tall and weighs roughly 500 pounds. In the following animation, we will show how the RVP4 performs the measurement of RVP. The BARTEC RVP4 is a piston expansion RVP analyzer. At the beginning of the cycle, the measuring cell is flushed with incoming sample to remove previous particulate, debris, and or other contaminants. Once a sample has flushed the cell and the cell is loaded, we can start the expansion by pulling the piston in order to reach a 4:1 expansion ratio or a 20% liquid to gas ratio. Once the liquid is expanded, vapors start to release and the pressure in the cell starts to build up. All of this happens while the measuring cell and the sample are maintained at 100 degrees Fahrenheit or 37.8 degrees Celsius temperature. And once a stable pressure has been reached, it is recorded as the RVP, read vapor pressure measurement. Once the RVP is recorded, we flush out the sample with new sample and get ready for the following cycle. Now that you know how the RVP4 looks like and operates, let's take a look at some of its features. The RVP4 is manufactured at our BARTEC Benki factory in Rheinbeck in Germany. It is a Class 1 Div2 or ATEX IEC-EX Zone 1 analyzer that uses a purged or EXP type protection method. The RVP4 is also compliant to ASTM D5191 and 6377. The RVP4 uses a full piston for the RVP measurement and has a range from 0 to 230 psi or about 0 to 16 bars, with a repeatability of 0.02 psi or 1.5 millibar, typical on gasoline application. Finally, the measurement cycle takes 7 to 15 minutes depending on the application, including heating and cooling cycles required to achieve the 100 degrees Fahrenheit of the RVP measurement. Regarding some of the benefits of the RVP4, the RVP4 is suitable for a whole array of samples, including crudes, LPG and LNG type applications, and refined products. The RVP4 also has a simple maintenance approach designed in mind to minimize the time required to maintain this analyzer up and running. The RVP4 also has an integrated temperature controller that allows measurements of vapor pressure at temperatures other than the typical 100 Fahrenheit or 37.8 Celsius required by the RVP. By going all the way up to 60 degrees centigrade or 140 degrees Fahrenheit, it allows measurement of TVP, for example, for storage applications. The RVP4 is not only suitable for crudes, it is suitable for highly paraffinic and highly viscous crudes due to its design with no flushing required in between cycles. This minimizes the amount of flushing fluid required as well as maintenance and shortens the time in between different measuring points. Finally, both our BARTEC Orb in Chicago and BARTEC Benki in Germany factories offer integration services that allows to build and provide a full turnkey solution for RVP4 type measurement analyzers. Now that we've spoken about the features and benefits of the RVP4, let's go over some of the typical applications the RVP4 is being used on. The first family would be gasoline application, and more specifically, blending application. Whether it is blending of gasoline at the refinery and or at terminals, or blending of diluents such as ethanol in the case of biofuels or carbon positive fuels, or simply butane in gasoline blending. In the case of LNG and LPG application, we often see measurements of RVP on condensate from stabilizers and or coolers, as the condensate is oftentimes a component of the gasoline blend. Finally, crude oil applications consist of measurement of RVP of crude after stabilizing or degassing, and in the case of blending application where either butane or various crudes are mixed together prior to being fed into a pipeline grid or to a refinery. With hundreds of RVP analyzers installed around the globe and decades of experience with analyzer systems, you can trust BARTEC to provide reliable and high-quality solution optimized to your needs and designed for tomorrow's requirement. Reach out to us and you will see the difference that expertise and excellence can bring to your project. Thanks and have a nice day.